Welcome to the pre-calculus. This session, we're gonna study rational function. We studied polynomial function, quadratic function. Now, our attention to the rational function. Rational function has different characteristics, key features. First, you identify what the rational function is. Second is, this is very important, guys. You decide, find the domain of rational function. Third, identify vertical, horizontal asymptote line of rational function. Then you're gonna sketch the graph of rational function using key features. So please keep in mind, the domain is so important for the rational function. Then you have to know how to identify vertical, horizontal asymptote line. First, what is the rational function? So first one is f of x is p of x over q of x. Numerator gonna be polynomial function, denominator gonna be polynomial function. This form we gonna say rational function. But when you're talking about rational function, you have to keep in mind, denominator cannot be zero. You cannot forget it. Denominator cannot be zero. That's decide a lot of things about rational function. So let's do first example. Find the rational function. I give 4 different form of function. Identify rational function. Which one is rational functions? F of x, 2x plus 1, x minus 3. That's gonna be rational function because degree 1 polynomial, degree 1 polynomial. G of x also, x squared minus 4, x plus 2. That's also rational function because degree 2, degree 1 polynomial. H of x is radical function because radical form. K of x is absolute value of x. That's gonna be absolute value of function. Guys, make sure rational function is polynomial over polynomial. When you see the rational function, this one is, guys, look at this one. This one is gonna be denominator, gonna be degree 1, numerator degree 0. This is rational function. We know how to sketch this function. What you have to do first when you see the rational function, find the domain. Domain gonna be denominator cannot be 0, right? So x cannot be 0. So we exclude x equals 0, guys. How can find the domain in interval notation? So you're gonna draw the number line. X equals 0 is exclude. Guys, please exclude. Exclude meaning is that the whole here, then you're gonna take any x value except x equals 0, guys. So how gonna write interval notation is negative infinity and 0, 0 and infinity, union, except x equals 0. That's your fine domain of rational function. Second part is g of x equal 1 of x squared minus 1. Denominator cannot be 0, right? So we're gonna solve this one. X squared minus 1 cannot be 0. 1 is moved to the right. X squared cannot be 1. X cannot be not just 1. Positive negative 1. Very careful with that. So x cannot be 1. X cannot be negative 1. So draw the number line, guys, here. Make sure negative 1. 1 is exclude. Exclude meaning is you have draw the whole here, each value. So except x equal negative 1, x equal 1, you draw the line right here. So here is x 1 and infinity between negative 1 and 1. X equal less than negative 1. So you have interval notation for domain. So negative infinity and negative 1, negative 1 and 1, 1 and infinity. You're gonna put the union right there. Make sure, guys, when you see rational function, you have to find the domain. denominator cannot be 0. If you x value which make a denominator 0, you're going to exclude from the domain. Now, let's understand domain range from the graph. I sketch f of x equal 1 of x. You guys already practiced sketch rational function. F of x is 1 of x. Look at this graph. So, first you notice it. X domain, we want to find the domain here. X equals 0. This is vertical line. X equals 0 doesn't have any point on the graph. So domain gonna be negative infinity and 0, 0 and infinity union. Same thing is range. Look at the y value. Here is this line doesn't have any point. So range for the rational function gonna be this line. That's the horizontal line, which meaning is y value is 0, right? The range is gonna be negative infinity and 0 and infinity. What's the role of x equals 0, y equals 0 for rational function? That's I'm gonna discuss next slides. Previous slides we talking about domain and range of rational function f of x is 1 of x. So when you're talking about domain range of rational function, we exclude x equals 0, y equals 0. That's important role for asymptote line. Let's start vertical horizontal asymptote line from the graph. So let's talking about this one, x equals 0. That's vertical line, guys. What kind of character they have? So this one is moved. This graph moved to the x equals 0. That's moved to the right. That's gonna be, graph gonna be go up. So this graph is getting close to this direction, 0 right here. Then graph is move up. In mathematically, right, x approach 0 positive, which means coming from the right. Then fx is go up is increasing. That's how you write it. Another one, guys, here is the bottom right here. X is approach to the 0 to the left side. Then graph is go down. Go down meaning is fx go to negative infinity. So we're gonna say as x approach to 0 from the left, f of x is go down in mathematically negative infinity. That case, we're gonna call this line x equals 0 is vertical asymptote line. Intuitively, vertical line, graph is getting close to the vertical line. That's you understand from the graph. X equals 0 is very close to the graph, but never touch it. That's the vertical asymptote line. Guys, make sense? Now, let's go to the other side. And behavior here and here. What's going on here? X go to the infinity, which meaning is x is increasing. Graph is getting close to this line. What is value? Y equals 0, right? So f of x getting close to 0. So x is increasing, fx is close to 0. That's in the behavior right here. The other side, as x approach the negative infinity, going to the opposite direction, we call x gonna be negative infinity. Graph getting close, y equals 0, right? That's x-axis. So x approach negative infinity, fx going to 0. That's gonna be horizontal line. Name of this equation is y equals 0. We call horizontal asymptote line. So simply say, graph getting close to vertical horizontal line. We call vertical asymptote. We call horizontal asymptote. But horizontal asymptote show, represent end behavior. You should remember that. Let's explain asymptote line one more time with the graph, guys. Okay, so that's the rational function x minus 1 over x minus 3. Can you notice what is vertical asymptote, what is horizontal asymptote? So first, x equals 3. Can you see the x equals 3 vertical line? This vertical line doesn't meet graph, right? That's right. Another line, horizontal line. x equals 3, y equals 1. Y equals also doesn't meet graph, okay? That's y equals 1. You notice x equals 3, y equals 1, right? So let's just start here. What happened? What's the behavior around x equals 3? Graph getting close. What do you write? X approached 3 positive, fx is go up. That's we call this one is vertical asymptote. The other direction. Here, same thing here, guys. Same thing here. Go down, which meaning is x approach 3 negative coming from the left. Graph is going down. Negative infinity. That case, we're gonna say this line vertical asymptote line. We're gonna say vertical asymptote line. Intuitively, vertical line graph is getting close. Same idea to the horizontal asymptote, y equal 1. And behavior, guys. Here, right here, and behavior. X is go there, graph getting close, y equal 1. X is going to infinity, graph close to 1. The other here, left side, x going to negative infinity, fx going to 1. So this line gonna be horizontal asymptote. X equal 1 is horizontal asymptote line. I want you to understand horizontal asymptote, vertical asymptote from the graph clearly. First big question is, we identify vertical horizontal asymptote from the graph. The vertical line, horizontal line never touch the graph. That's what we call vertical horizontal asymptote line. But how gonna find the vertical asymptote line from the function? So you might notice from the domain and vertical asymptote line, we know how to find the domain. We exclude the x value which make denominator 0. That's gonna be vertical asymptote line, guys, okay? So look at this. X minus 3, guys, look at this graph. I sketch it. Vertical asymptote line, this line, x equals 3. This is not included in the domain, which meaning is denominator gonna be 0. That's gonna be vertical asymptote line, x equals 3. So x equals 3 is not in the domain. At the same time, x equals 3 vertical line is vertical asymptote line, okay? Now, I give the function, if denominator cannot be factor form, you have factor first, but I gonna give factor form, guys. So denominator right here, how gonna find vertical asymptote line? Thinking about finding domain, guys, okay? Denominator 0, 3x minus 1, x plus 2 equals 0, which meaning is 3x minus 1 equals 0, x plus 2 equals 0. Solve this linear equation, x equals 1 over 3, x equals negative 2. That's gonna be vertical asymptote line. At the same time, you have to exclude this point from the domain. Let's check from the graph. So this is graph of f of x. Did you find the vertical asymptote line? First one is right here. Second one is right there. This is x equals negative 2. This is x equals 1 over 3. That graph confirms your answer. Let's find this one, guys. K of x, 4x squared over x squared plus 4. I told you vertical asymptote is related to the domain. So find the vertical asymptote, meaning is x squared plus 4 equals 0. Can you find x value? You cannot. This one is no solution, guys. This one is no solution, which meaning is no vertical asymptote. So look at the graph. This one is no vertical asymptote line, which meaning is no vertical asymptote, meaning is domain is only a number. There is no vertical line. Here, graph doesn't touch. Here is every x value has y value. So domain of this rational function is only a number, which meaning is no vertical asymptote line. We've learned how to find vertical asymptote line algebraically. Now, let's talk about horizontal asymptote line. This is more tricky compared to vertical asymptote line. So how gonna find horizontal asymptote line, guys? Okay, let's do this one, guys. This one is graph of f of x. Horizontal asymptote line, this one. What is the name of this equation? Y equals 0, right? So how gonna find it? So how gonna find the horizontal asymptote line from the form of equation? You have check degree of numerator, degree of denominator. You have check degree both. So first, degree of numerator, degree of denominator. Degree of numerator is 1. Degree of denominator gonna be 2. Which one is bigger? This number is bigger. That case, horizontal asymptote gonna be 0 all the time. Degree of denominator is less than degree of numerator. Horizontal asymptote always 0. Another case, guys. This is f of x, 3x squared over x squared minus 9. Where is the horizontal asymptote line? Did you find it? This one is horizontal asymptote line. That's gonna be y equal, can you see? 3. Y equals 3. How gonna find y equals 3 algebraically? I said check the degree. Check the degree of numerator denominator. What is degree of numerator? 3. 2. I'm sorry, guys. That's coefficient. Degree is 2. What is the numerator of... what is the degree of denominator? That's also 2. Exactly same. Then we always check coefficient. What is coefficient on the top? Numerator, 3x squared, coefficient is 3. X squared minus 9, highest degree x squared, coefficient is 1. Y equal 3 and 1. Y equals 3 and 1. That's gonna be horizontal asymptote line. Let's another example, guys. This is f of x, 3x cubed over x squared minus 9. So I sketched the graph. Can you find the horizontal asymptote line, this graph? No, there is no horizontal asymptote line. So how gonna find algebraically, guys? Check the degree of numerator denominator. So numerator, degree of numerator gonna be 3. Degree of denominator gonna be 2. Which one is bigger? Degree of numerator is bigger, right? That case, no horizontal asymptote. Okay? Let's summarize horizontal asymptote line in the next slides. So how gonna find horizontal asymptote line? You have polynomial in the numerator, polynomial in the denominator. You have checked the degree. Here is degree m, here is degree n. So check the degree each time. If degree of numerator is bigger, that's gonna be no horizontal asymptote. Degree gonna be denominator is bigger, y equals 0. Degree is the same, numerator and denominator, guys. Then you check the coefficient. Y gonna be am over bn. Okay, guys, bn. So horizontal asymptote gonna be am over bn. What is the key features of rational functions? Okay, guys. When analyzing rational functions, you identify a couple of things. The first, domain is first, guys. But domain is related to the vertical asymptote line. They're so related, guys, okay? Third one is horizontal asymptote line. Then you're going to find the x-intercept, y-intercept. When you find each feature, you can sketch the graph of rational function. Let's sketch the rational function. First, we want to find the x-intercept, y-intercept. How gonna find the x-intercept? Y equals 0, right? F of x equals 0. X minus 3 over x minus 2 equals 0. You're gonna times x minus 2 both sides. X minus 2, x minus 2. X minus 2 is cancel out. 0 times x minus 2 is 0. So x plus 3 equals 0. x equal negative 3, x-intercept gonna be negative 3 and 0. You find the first intercept. Now, I want to find the y-intercept, which meaning is x equals 0. You plug in x equals 0 in function. F of 0, 0 plus 3, 0 minus 2. 3 over negative 2 meaning is negative 3 over 2. So y-intercept 0, negative 3 over 2. You find the x-intercept, y-intercept. Now you're going to find the vertical, horizontal asymptote line. You will identify domain range later. Let's find the vertical, horizontal asymptote line. Vertical asymptote line, how going to find it? Denominator gonna be 0, right guys? Denominator 0. So x minus 2 equals 0, meaning is x equal 2. That is a vertical asymptote line. Horizontal asymptote line, check the degree, right? What is the degree of numerator? 1. Degree of denominator? 1. Same degree. So you're gonna coefficient is 1. Coefficient gonna be 1. So y equal 1 over 1 is 1. So horizontal asymptote equal y equal 1. Now, we know the x-intercept, we know the y-intercept, we know the vertical asymptote, we know the horizontal asymptote. Start with the vertical horizontal asymptote line. X equal 2, you're going to sketch first. That's vertical asymptote. X equal 1, you sketch horizontal line. Then you plot x-intercept, y-intercept. X-intercept negative 3 and 0, y-intercept 0 and negative 3 over 2. This is horizontal asymptote. This is a vertical asymptote. You're not going to touch it. Getting close. So you're going to sketch this side. Can you sketch it? You're going to sketch this side. This line is getting close, horizontal asymptote line. Getting close, vertical asymptote line. The problem is you have sketched this side, the other side, right? That case, x is less than 2, you sketch it. Now you're going to sketch x is greater than 2. So you're going to plug in any number. X equal 4, plug in here. F over 4, 4 plus 3 over 4 minus 2, 7 over 2. So x equal 4, 7 over 2 right there. Guys, plot it right there. You plug in another number. X equals 6. F of 6, 6 plus 3 over 6 minus 2. That's the 9 over 4. You plot the 9 over 4. Connect it. Vertical, horizontal asymptote line, guys. Don't touch this asymptote line. You sketch it. A lot of students forgot the other side. Make sure you sketch the other side. That's how to sketch rational function. Let's practice one more time, guys. This is rational function you have, right? So find the x-intercept, y-intercept first. What is an x-intercept? Y equals 0. You plug in the y equals 0, which meaning is fx equals 0. So you times x plus 4 both sides. So you have 0 times x minus 4 is 0. This is cancel out. X plus 4 cancel out. X minus 1 equals 0. X equals 1. That's you find x-intercept. What's the y-intercept? X equals 0. You plug in x equals 0, 0 minus 1, 0 plus 4. That's the negative 1 over 4. You find it. Y-intercept 0 and negative 1 over 4. Next one is vertical and horizontal asymptote. Vertical asymptote line gonna be denominator gonna be 0, which meaning is x plus 4 equals 0, x equals negative 4. That's the vertical asymptote line. What is horizontal asymptote line? You have checked the degree. Numerator degree is 1, denominator degree is 1, same degree. Horizontal asymptote gonna be y equal 1. We have all the information, all the future for the rational function, x-intercept, y-intercept, vertical, horizontal asymptote line. You always start vertical, horizontal asymptote line. X equal negative 4, you're gonna draw the vertical line. X equal 1, you sketch the x equal 1. Now plot the x-intercept, y-intercept. 1 and 0. 0 and negative 1/4. You connect to this point, getting close, horizontal line, vertical line. That's sketched that side. You have sketched this side, you plug in the number. X equal negative 6. F negative 6, negative 6, negative 1, negative 6 plus 4, negative 7 over negative 2. That's going to be 7 over 2. So it's negative 6 right here, guys. 7 over 2. Negative 6 over there, 7 over 2. Another one is x equal negative 8. So f negative 8, negative 8, negative 1 over negative 8, 4. So you have negative 9 over negative 4, 9 over 4. So you have negative 9 over 4. Then you're going to connect the point right there, guys. Then you're going to sketch the function. Make sure you guys start with the vertical horizontal asymptote, plot x-intercept, and find any 2 points connected to the other side. What do you learn this session, guys? We learn rational function is a fraction of 2 polynomial, and domain excludes value that make denominator 0. Also, this one is related to vertical asymptote. Vertical asymptote gonna be x value that makes denominator 0, right? Horizontal asymptote, they describe end behavior. You have checked degree of numerator and denominator.